Dear professors and fellow friends, I am Cemal. Today, I will talk to you about how data transmission is made with visible light and the working principles of the circuit used. In transmitter circuit, we generally use a 4-state RC coupled amplifier using transistor BC337. Capacitor 4.7 microfarad is for blocking DC signal. Combination of 4.7 kΩ resistor and 1 kΩ resistor is for voltage divider purpose, and audio jack is for input signal. High illuminated LED is for transmitted signal purpose, and 9-volt battery for power supply. A resistance capacitance coupled amplifier is basically multi-stage amplifier circuit extensively used in electronic circuits. Here in the individual states of the amplifier are connected together using a resistor-capacitor combination, due to which it bears its name RC coupled. The circuit shows such a 4-stage amplifier whose individual states are nothing but the common emitter amplifiers. Hence, the design of the individual states of the RC coupled amplifiers is similar to that in case of common emitter amplifiers, in which the resistors 4.7 kΩ and 1 kΩ for biasing network, while the emitter resistors are a form of the stabilization network. In addition, in this circuit, the voltage drop across the collector emitter terminal is chosen to be 50% of the supply voltage, VCC, in order to ensure appropriate biasing point. In the receiver circuit, I used solar panel for receiving input signal and 1000 microfarad capacitor treated as a bypass capacitor, 10 kΩ potentiometer for polling purpose, and operational amplifier LM386 for using signal amplifying, and 10 microfarad capacitor for increasing gain, and the other 10 microfarad capacitor is for using blocking DC signal, and speaker is for use take output signal. Here is the implementation of audio transmission circuit via visible light communication. It is clearly seen that our LED is flickering bit by bit. In this video, the noise that occurs when we put the solar panel in a position where we cannot see the signal coming from the LED will be shown, and distortions in the sound will be clearly noticed. Now we are hearing the noisy sound because the solar panel is wrong position. Here is the text transmission circuit. I will mention about used hardware and circuit schematic. Another way we transmit data is the on-off keying method. In this method, we need coding, transmit and control the data. It is an easy method to implement. We have transmitter and receiver circuit as in previous circuit. High illuminated LED is used for our transmitter circuit, and BPW21 photodiode is used in our transmitter circuit and receiver circuit. The communication between the data and the computer is STM32 is used. Now we can move on to the coding part. Here is the transmitter code. First thing we will do is define pins for the LED and the button. So button for PA0 and LED for PA1 is selected. We have to set up the pin mode of the LED and the button. LED is an output, button will be an input pull-up. This setup is as a pull-up because if you look at the circuit, button is connected directly to the ground, so we need some way to pull it up to 5 volts. When this is not connected, so basically what happens is that when you don't connect them, you don't press the button, the voltage is 5 volts. When you connect, the voltage will be 0. You are sending data period by period. So after that, here is an input pull-up pin mode. Here is a pin mode, LED is output, and here we define the period. Then void loop is for we have to base read the data from the button with state, then reflect state on the LED. Then we will write what we see on the button. Since when we don't press the button, voltage is 5 volts, and when we press it, voltage is 0. We have to change it. We want reverse station, and we are trying to invert it. How can we invert this station? So we are using not. Here we see now not operator. Void send byte. We will transmit the data according to protocol as an argument to this function. I pass byte the date 1 to send. We need to make sure that the voltage is low for one period. So here we define the period. Now for the transmission of bit, I have to do something such that depending on this byte, I send one byte at a time. Here we see now. Here is our voltage is low, and we sending data in a period. For loop is for bitwise operation. First thing we do is get our byte. So here we are using for loop to do this 8 times. Here we seeing send data bit by bit, and then entire is equal 0, and then we are shifting by bit, so we are produce our mask so that it will be 0x01. Then we are checking if our bit is 0 or 1. Then we determine the length of the string. Here is the length of the string. For the length of the string, here we data sent by bit by bit. So the length will be is smaller than this for loop. Here is the receiver code. First of all, we are defining our LED, photodiode, threshold value, and period. Period will be same because we are sending data in the same delay. Here is the Boolean expression for previous state and current state. It can be set that it will be 0 and 1. Here is the void setup. For void setup, where serial begin in 9600 as chosen, because it will be the 100% accuracy can be select. Here is the pin mode again. LED is chosen as an output. For the void loop, our current state is getting LDR for the 0 or 1. Then we are checking it. If the current state is not equal to previous state, print get byte. So we are falling edge and rising edge can be think about that station. And for the Boolean expression and getting LDR, we are integer voltage alone bit for LDR pin. Is it threshold value, over threshold value, under threshold value? Is it under threshold value? It's false, and if not, it's true. We are getting the byte by char. If our char is equals 0 for in a period, then we are taking the bit for in a for loop for the getting the byte 1 to 8, and redirection the LED. If our char string length is equals to the same meaning, we are taking the data by 1 byte. Then we are returning redirection. Here is the void print by char might. Here is the control testing. We are converting the char for the string in a buffer. It's equals 2. I think it's enough. And we are printing our buffer in 100C for our mybyte, and we are serial printf in a serial port. Hello again. I will explain in this video why do we need the threshold value. Here is we seeing now the noise signal is coming our LDR or solar panel, we can say. Then we are sending data by the threshold value, and we are seeing that here is a 320 candela in a second. We are seeing sending by sending, and then we choose our threshold value, and over the threshold value is meaningful. and here is the our noisy signal, but it cannot affect our solution. Then we are sending the data byte by byte. So we are seeing that on-off keying is successful in this project. Here is a serial port screen we are seeing now. I took this video about one month ago, and we will see that here is the transmitting data in a real time. We are sending data byte by byte, and it is so clear that our message is sent by 100% accuracy.